1.6 is all about fractions, and we want to take everything down or make sure we understand everything in terms of composition. Okay, and so this is going to be a little different than starting out with like what's a fraction and so on. So there is a couple of things with this. Multiplying fractions. So again, if we get something like 2/3 and we're multiplying it by 2/7, right? So the idea of a fraction and what it represents is one thing, but I just want to look at this in terms of composition. When I see something like this, first of all, I'm multiplying between these, right? So what I need to do is recognize individual factors. And it's because we're multiplying, okay? So this is actually equal to, it's the same thing. So when I multiply fractions, you multiply straight across the top. So you take 2 times 2, right? Well, what that creates is 2 factors of 2 in the numerator. In the denominator, you multiply across that. This would be 3 and 7. Now, when I look at that in terms of composition, how many factors do you see here? How many factors do you see in this expression? And because of the parentheses, I see 4 factors, right? Now, as we multiply, recognize individual factors. There's actually 4 separate factors here. So when I multiply, I can write my answer, right? 4/21. But the big thing is just recognizing factors in that. Any questions? Now, if we had a bunch of factors, and I need to use the space to the right here, I guess. Say I had another example over here. When I have numbers that I'm multiplying, these are all factors, right? And there's fractions that are in there. But when I have numbers that are just plain numbers like this -3 and this 5, I realize that those really are the same as factors. Well, why can't I draw? Oh, my pen's probably dead. I have to keep reminding myself that I need to do that over. Anytime I have a straight integer like this, I can see it as a factor of -3/1. So anytime I have a number, it's a fraction over 1. Now, the 5 is the same as a factor of 5/1. And all this does is help me line up all the factors in the numerator and all the factors in the denominator. That's all it does. So this is a good way to think about the numbers as you see them as fractions. But when I multiply, I'm not multiplying any different. This is still going to give me, in my fraction, it's going to give me a -3, a 1, a 5, a 1 in the numerator. Those are all the factors in the numerators of those fractions. In the denominator, I'm going to have a 1, a 4, a 1, and a 7. Do you see them all? And what I did is I wrote it as one big fraction where all the factors in the numerator are together and all the factors in the denominators are together. Does that make sense? Now, the ones, do I really need to keep track of factors of 1? Because when I multiply by 1, basically nothing happens, right? So the main factors that I care about are -3 and 5 on top and 4 and 7 on the bottom. Now I want you to look at kind of what we started with and think about what factors are important. Okay, so again, it's just seeing the factors for now, just seeing the composition. We'll get our answer, but that's not the important part here. How do you see factors or recognize individual factors, right? So we'll always end up with factors in the numerator and factors in the denominator. Cool? Look at the factors that ended up in the numerator. So if I do those in this magenta, -3 and 5, they ended up in the numerator. The 4 and the 7 ended up in the denominator. You see that? So what we call the factors in the denominator are fractional factors. So when I have a 4 in the denominator, the factor is actually 1/4. It's a fraction. 7 in the denominator, it's 1/7. So I know we're kind of itching to get this answer. What's the answer to -3/5? -3 times 5 would be -15 in the numerator, and the denominator is 28. But it's not so much the answer, it's understanding when I see fractions, what I care about is how to find the factors in the numerator and the denominator, these fractional factors. Okay, again, I want to make sure we're using composition. So the first thing is reading it. When I have a fraction, how do you see the individual factors? All right, so let's look at identifying fractions or identifying fractional factors. Division, we're going to get into, but if somebody said, what is half of 10? How would you calculate that answer, right? So if somebody, what is half of 10, right? And you could just hold up your hand if you want, but I don't, or Sienna or Leonard, you could take yourself off mute and just say it, but what's half of 10? Of course, the answer is 5, right? Yeah. So how did you actually get that value? Okay. And Sienna, how did you get that? What did you actually do? You started with 10 and then divided by 2 and we get 5. Okay. Now, if you translate this, it's exactly the same thing as if you took 1/2 and multiplied it by 10. And this would give me, which is a fraction, right? And that's why when you see fractions, they basically represent division, correct?
Yes.
Okay, but notice how the divided by 2, this division by 2, is tied to the 2 in the denominator. Isn't that what it is? So here's what we have. Division by 2 becomes a fractional factor of 1/2. So the divided by 2 is the same as a fractional factor of 1/2. It's really important that we look at factors. And all I'm saying is that every division problem, when you divide, and that's the division symbol, we invert and multiply. And it doesn't matter what fractions you have. Basically what this is saying, dividing by a fraction is exactly the same as multiplying by the reciprocal. This is a big key, and it's also listed in the red box in your book. So notice here, A divided by B is equal to A times 1 over B, which is the same as A over B. The big thing to notice is that the factors are A and the fractional factor of 1 over B. Okay. Again, it's not just tell me how to get the answer. What we're doing is basing this all on composition. So I want to read and understand how to see the factors in everything I do. So in a nutshell, it's not about finding answers yet with fractions. What it's about is understanding how to recognize factors when I have fractions. So we're only going to be